Okay, here we are. Sorry for the delay. It's May 14th, the Digital Roundtable. We're going to talk semiconductors today and all kinds of things around that, automation and energy, and we'll talk about autonomous vehicles and battery management and where the world is going. And we'll get Bryan's view of the planet and how fun it is to be alive today. But before we get going, let's have our own John Sibley Butler play some music.
I wish a buck was still silver. It was back when the country it was strong. Back before Nixon, before the Vietnam War came along. Before the Beatles and yesterday, when a man could still work and still would. The best of the bright days behind us now, and all the good times really over for good. And are we rolling downhill like a snowball headed for hell? No kind of hope for the flag of the Liberty Bell. I wish a Ford and a Chevy still last 10 years like it should. It's the best of the good days still yet to come, and the good days ain't over for good.
Woo!
Bryan, you don't know that. That was before you were born. You never heard that song before.
Beautiful, though. Thank you.
How you doing, Bryan?
Doing great. And yourself?
I'm doing good.
All right. Well, Johnny, the world is going nuts about China and the deal with the Saudis and potentially the deal with Qatar and potentially the deal with the UAE. And the stock market is now through the roof. What's going on, John?
Well, you know,
John
the problem
Butler?
is how we think about the world. I don't know why we think the world should be in equilibrium and total good all the time. Actually, the world is always in chaos, and equilibrium is goodness. It just lasts for a small amount of time.
Right.
So I think that it's like economics. They say, well, there's equilibrium theory. No, the world is economics is in constant chaos. There are jobs being created, companies being created, people getting fired. So there's no such thing as equilibrium. So I want to say that the question is, how do we get through, as I just saying, is the good times really over for good? Well, you know, I think with the deal with Qatar, I think that's good. I think with the plane, I think he should have just put it in Trump's at the president's library. You know, wealthy people barter all the time. Wealthy
Mm-hmm.
people barter. They don't sell. And if they like you, and if they own a house, they'll give you a house. They'll give you a castle or whatever have you. But we can't take that plane because of the you know, the security issues, right? But other than that, you know, I think that we are in a deep experiment with this president, and this president will either be an Andrew Jackson, you know, who you know, responsible for the balancing of the budget and also the removal of the Indians, or he's going to be a Lincoln who was responsible for the end of slavery. Big ideas that really changed the world. And then the question is, can this president pull it off? And I think we're all being pulled along by this great experiment. And no matter what our attitudes are, these experiments are happening. So you can see that some of the numbers are pretty good. The inflation really dropped. And by the way, I think this experiment is more about Western civilization than America. I think it's more
Mm-hmm.
about what happened with Western civilization as opposed to what we call the Far East or China. Would China be a superpower in the future. And I think that we should not demonize China. I think we should say that they've done great things in what they've done, and it was absolutely great experiments. What we have to worry about, I think, are supply chains. And you take the semiconductor industry, right, which I think is projected to hit $1 trillion by 2030. And if you look at all the changes in the semiconductor industry with AI coming on and what conductors can do, and I'm still thinking that it's a relationship between the glass, right, and the electricity that they conduct. If
Mm-hmm.
and that's very, very important because, right, going forward, we have the data centers to build out. And I think you're going to see a decrease, for example, in personal computers, right? And an increase in data centers, what we used to call the old mainframe. So I think the
Mm-hmm.
semiconductor industry has to be up to par to do that. But it really doesn't say that the supply chain is done. With the materials that's needed, we need to concentrate on the supply chain. Deals will be made. And I said this, as I said, this grand experiment in America will be very, very interesting, and it will be a hard pill to swallow, both
Mm-hmm.
both intellectually and both philosophically. Philosophically, it's a hard pill to swallow to say that I don't know, public radio should not be funded since it's been funded since, I don't know, 70s or whenever it started, right? It's just a,
Mm-hmm.
and so the
Yeah.
question is, as we move forward, at the center of all of this, everything that we're doing, right? Deals now are completely related to supply chains, right? And the digital economy, right? So if you don't have any supplies, if you don't have any rare minerals, why cut a deal, right?
Mm-hmm.
And I think that if you look at the way we're going in this, what I call this social physics, the flow of spaces, right? Flows of how information flows and changes people's lives, right? The question
Mm-hmm.
is, can the technology keep up? And the big question is, who will own the technology?
Right. Right.
With chips, what we used to call them, with chips, we're made of wood in the future. Scientists are looking to that. What would be the relationship between PCs, and chips and mainframes and chips? But the big part is we know that going forward, that chips are very, very important. But what will AI do to the cells? What will AI do
Mm-hmm.
to how they are designed? I mean, what can they deliver? I mean, different chips are for different kinds of things as they conduct a relationship between the glass and the electricity. So I think that we're in for a good ride. And the other thing is that in looking at Andreas, all of the issues that we have, as Llewellyn would say, he's not here, so I'll try to think of what
Mm-hmm.
to say is, what would jobs look like? We have an issue right now, as I say, that what technocrats like myself did, we created a lot of wealth for 50% of the population, and our kids are now in the gig economy with no retirement, no great job, finishing college, and there are no great jobs, no great opportunities. And of course, you should see them also leave America and go to other places.
Mm-hmm.
Why not take a job in China? Why not take a job in the Middle East? Why not take a job somewhere else? So I think that as money flows, so do people flow. People flow to America because America was the greatest collection of minds and universities in the entire world since perhaps the 1300s in the Roman area, right?
Mm-hmm.
And the Egyptian area. So I think that the flow of people, right? The flow of
Mm-hmm.
people and the continued flow of money in science and invention, right? Not management, not accounting, not finance. Science and invention has always been what made America great in terms of opportunity.
Yeah.
I taught in China. I won't say that I started the Great China Revolution, but I won't go that far. But I do have ex-students who are running companies in China. I taught in the MBA program at the University of Beijing. And what struck me there when I was there was that most of them were majoring in sciences. 70% of their students were majoring in sciences, biology,
Mm-hmm.
chemistry. psychology, the social sciences, sociology, economics. Whereas 70% of our kids want to major in business. But it's
Yeah.
the inventions that create the opportunities for business. I'm sitting here looking at Bryan and asking me, what is that damn thing behind you that I'm looking at, Bryan? What is that? Is it the original phonograph?
Sure is. So we
Bryan,
got
how many jobs do you think that thing created? Bryan, when it first came out, there was a love song that came out during the Civil War, and they had to stop playing the song because people were running away and deserting. And it was because they could listen for the first time to the song on that phonograph. Bryan, do you know what that song was?
I do not.
I want you to look at it. Leanna. I want you to look it up. Just do Civil War song, Leanna, right? And because of the contraption that you see behind you, right? Then we'll make sure people would listen to it, right? And they would say, I'm going to run away from the military. Well, it went from the north to the south. Did you see it? Do you see it?
Liana.
L-E-L-O-R, Lorena. Lorena.
Oh, Lorena.
Yeah.
Oh,
You never heard of it. It's the
no.
first song that was done, that was heard on that phonograph behind you. But the thing is, it created many of jobs. Lorena, right? Lorena,
Interesting.
right? I want you to look it up and listen to the words, and you will say that this is the
Yeah.
first technology. No, you don't know it. You don't know it. You don't know it because they don't teach that anymore. They teach you that's not but I learned it there, you got it? You have it?
1856.
Huh?
1856.
18.
18, what's the
Webster.
name of the song, Andreas?
Lorena.
Loreena, right?
Lorena. That's correct. It was Reverend Henry Webster first penned the lyrics in 1856
Right.
after fiancée Ella Bloxham.
All right, it goes like this. The years have creeped slowly by, Lorena. Snow is on the grass again. First song. The Frogs, first song, right? It was so romantic. When the soldiers heard it, they would desert, right? Again, it first started with they had to get back to their loved ones.
Oh,
But my
Lord.
point is that phonograph created so many jobs for people. So that's where we are.
Yeah.
Where you are now, you are where that phonograph was in the mid 1800s, right? Changing people's life. Wait a minute now, Bryan. I know you like that song. I want you to find it on the internet. I want you to listen to it, right? It's the best love song that's ever been created in America. I know
Let
it
me
because I'm from the state of Louisiana and I'm a musician. And I learned it when I was ninth grade or something, right? But
let
the
me
point
let
is,
me
my
let
point
me let
is,
me let me chime in, Johnny. Let me chime in
yes, right.
and share. Can you guys see my screen?
Yeah.
So this is the update on Texas semiconductor industry. So
Right.
we're the number one exporter of chips, 12 years in a row. We lead with the largest capacity since 2022. We rank number two in manufacturing, number of manufacturing firms. We rank number one as a state to do business with semiconductors. This is the export number. Look at this, 21 billion versus 11 versus 4 versus 2.
Yep.
Okay. I mean, Texas truly leads in semiconductor. And then the other thing I was going to show you guys real quick was this, So we have, the Governor's National Semiconductor Center Texas Task Force. We have the Texas CHIPS Act. We have the Texas CHIPS Office. We have the Texas Semiconductor Innovation Consortium. We have the Texas Semiconductor Innovation Fund to invest. We have, a significant workforce. So anyway, just wanted to give you guys a
And
sense of that.
remember, Andreas, how all of that started with the great semiconductor that we lost to the Northeast. Can I
That's
get your history? What was the name of that company that left us?
Sematech.
Semitech. Okay, I was just wondering if you remember, right?
Oh
So
yeah.
we've always been the leader in that. But remember that we can become the Sears and Roebuck overnight with China.
Mm-hmm.
We was,
Right.
you
If
know,
we
we
don't
had
watch it, if we don't
Andreas,
watch
when you
it.
were a kid, you had to go to and rent a movie and pay $5, and then another $2 if you didn't bring the tape back in time, right? From
Right, exactly.
Blockbuster, right? So what I
Exactly.
want to do is ask Bryan here. Now that I've done Llewellyn's part, I want to ask Bryan this. Bryan, what did you see with the
But
blockchain?
let
Yes.
me introduce Brian real quick.
Oh
Brian
yeah, we got to introduce Bryan. I'm sorry. Llewellyn
Brian
isn't here,
Keller.
so we're all confused. Yeah.
Brian Keller is the Associate Director of Systems Architecture at LNT Semiconductor Technologies. And LNT Semiconductor is an Indian headquartered company founded by two Danish guys. And it's a fabless organization owned by Larsen and Toubro, which is a $35 billion conglomerate that builds everything, power plants, solar farms, boats, submarines, you name it. They're what's called an engineering, procurement, and construction firm. And they were persuaded by the government of India to start a semiconductor business. So Bryan is one of those semiconductor architects in the company here, headquartered in Austin. They're building all kinds of things. So anyway, so welcome, Bryan.
Thank you very much for having me.
All right, Johnny, go ahead.
So Bryan, I know we give you a lot of. We started here in Austin. We had a big consortium that left. My question is that, like Ryan, it is so much going on in your industry. I want to start with the supply chain, the impact of the supply chain, what's happening in China on your industry. I want to know about the workforce in your industry, in the international components of your industry. How are things being affected in this great experiment, ungreat experiment that's happening in America now?
Wow, that's a loaded question. So in so many different ways. To just even try to take a swag at it, supply chains, where do you source from? Who do you source from?
Yeah.
There are semiconductor fabs all over the world. One of the strengths of being a new semiconductor startup, especially a fabless one, is we have that luxury of choice. We have that luxury of, for lack of a better term, infancy in the space, where we can actually pick and choose where our test is done, who is going to build our chips, what processes we use. More importantly, we're able to do that on a per product line basis. So for us, the impact is just right now how we do business. We're able to create some of our chips based upon geography, which is a big benefit to us that not everyone else in the industry shares.
Yeah, and Brian, tell us real quick the locations of the company and the focus on some of the product lines, perhaps markets to go you guys are building.
Yeah, so that's where LTSCT is actually fairly unique in the startup sense. Normally, when you start up a semiconductor company, you do it with one product in mind and really drive home the value on that product. For LTSCT, we're actually hitting several different areas at once. We have three main tiers of the company: mobility, energy, and compute slash industrial. And through those different verticals, we've been developing out full product lines and bringing different chips to market. So, for example, in mobility, it's everything from USB PD chips on the inside of the vehicle to next-gen digital architectures for actuators, codeless, headless actuators, really trying to work towards the new zonal architectures that are taking over. all the way to compute. And same thing with the other verticals as well. We're really doing a broad sweep on the market, with also a large focus on AI, of course.
Oh, well, look, go ahead. I'm sorry, Andreas, you weren't finished. I'm sorry.
No. I just wanted him to give us a sense for what markets does the company focus on, and then the locations, Bryan, that you guys, the offices in the company, where are they?
Right. So our design and test is centered out of India, with multiple locations in India. And then we have several field and product offices throughout the world. So our main headquarters for product development and design is out here, Austin, Texas. But we have other locations throughout the world, Germany, Taiwan, Japan, spread out.
Okay.
I have I have an interest in everything, right? But one of my great interests is how technologies change. And back in 2022 or something, they were experimenting with wood to replace the materials. Are you aware of that at all? Are you aware of the use of wood in semiconductors?
You got me there.
Gosh.
Sorry.
Well, I'm a professor. Can I share my screen, Andreas?
Yes, sir. Go ahead.
One of the things you got to realize is what I do. Can you see this right here?
Yes, sir.
Okay. So one of the things I do in my books on technology transfer is to look at how new technology changes business models, right? So one of the things that I've had a great interest on, and I have books on technology transfer, is not what we have today, but the new technologies in the laboratories that's being done by scientists, right? And this should be 21, or this was published in 22, right? So my question is a very, very simple one. First of all, I want you to understand, what I want you to do is understand, okay, that your business is very interesting, just like other material science, whether it's making artificial rubber, whether it's making, going from to artificial clothing, or whatever the piece would be. I want you to read this and reflect on it just real fast. It says the idea of making semiconductors from wood isn't as far out as it sounds. That's because cell walls in plants are made of a material called cellulose, and cellulose can be made to conduct electricity when heated to relatively high temperatures under certain conditions.
Sure.
So my question to you is, in your field of that you're doing, are you aware of what's going on in the laboratories so that you might have to change your business models based on new kinds of science? Oh, by the way, 512 CMD is not going to charge you for this knowledge and information at all. I'm going to stop showing that. I'm going to stop.
So the answer is yes, definitely. You did get me with the cellulose, though. That's very interesting. We're gonna have to look into that more deeply.
Yes.
So yes, for example, and maybe not as hot and talked about, or as novel as we'd like to think, but like, for example, wide bandgap semiconductors. It's one of the areas we're looking at more than just silicon. So yes, one of the nice things about this startup is they're not afraid to look at that big picture. Our CTO office is looking out for the deep integrations, those next big plays on where we should be developing and being able to find that product fit, and not just trying to capture the next 3%, 2% performance increase, but really trying to hit some deep goals.
So Bryan, I'm curious if you can help us get a glimpse of the world that most people don't understand. So how long does it take to make a semiconductor chip? What's the journey? How many days, how many hours, how many months, how many weeks? What does it take to build a brand new chip? Say you want to build a brand new chip that goes into a car or into a transformer or something. What does it take usually?
So generally, our product cycles match with the industry we're working with. The consumer cycle tends to be, on average, about a year. Now, on the semiconductor side, it takes us a little bit longer than that. But if you're a well-oiled machine and you're just making iterative improvements and marching down your technology roadmap, you can push out 1 to 2 years with new silicon.
Wow.
When we start looking towards automotive, that jumps up a little bit more, 1.5 to 3 years. But there's also a longer design-in period there as well, which tends to be on average 3 years. But we see that window shortening now, especially with the way the automotive industry is starting to work in places like China.
So what's going on in automotive semiconductor? What's the latest thing? Autonomous vehicles, what does that mean? What's being built? What are you guys thinking about?
So I'm going to be biased here because I'm going to go towards where I spend
Mhm.
most of my time. So on the EV space and the hybrid space, it's going to be traction inverters, wide bandgap semiconductors, the electrification of the vehicles, moving away from moving parts, replacing hydraulics with electronics. And that's on the hardware and drivetrain side, and even safety systems such as brakes, removing hydraulics from brakes. Um, and then, of course, also the compute side, making cars smarter, AI, whether the processing be at the node or centralized, increasing the information transfer in the vehicles, and just bringing a whole bunch of processing on wheels, and then also the export of that processing to the cloud. So it's everything we see going on around us in the consumer industry is coming to automotive as well. It tends to lag a little bit behind, but we see just complete ground up redesign and re-architecture of these vehicles. So for example, one of the things I talked about, zonal architecture. Currently, most vehicles are made on something we call a domain architecture for the vehicles. You can have hundreds, up to 300 different ECUs in a vehicle, and everything is focused around a certain domain, such as IVI or uh, uh, instrument video infotainment. You would have a whole system dedicated to infotainment. You'd have a whole system dedicated to braking, safety systems for sensors. Now, what we see, instead of having these hundreds of ECUs throughout the vehicle, is trying to simplify those designs to 3, 5, 7 main zone controllers, and really take the learnings from software and consolidate the hardware and make it a little more agnostic and make these really software-defined vehicles.
You know, Bryan, reminds me, my wife asked me, why are you speaking so loud, so softly? I said, because, you know, everybody's, Zuckerberg is listening to me. And she said, what? I said, I mean, they're listening to me. What are you talking about? Well, you know, Sirius laughed, my refrigerator laughed, and then my car laughed, right? So my point is that when you do, when you, in your industry, talk to me about the different requirements of so many different kinds of things where you're putting your semiconductors in. You hit on it earlier, right? Just think about this, you know, what you need uh, in terms of capacity, or is it the same capacity? How do you do that?
In terms of money or components?
No, in terms of if it goes in different kind of components. One might go in one technology, the other one might go in a cell phone, the other one might go in a computer, the other one might go in an automobile. Uh, are they all the same, or do they have different kind of requirements?
So
I think I know the answer, but I'm here. Yes.
yeah, no, you're leading me well. I appreciate it. So no, so with automotive, we have a vast.
Oh,
Are you there?
Yep, sorry,
Go
the
ahead.
desk a little too hard. So with the automotive, we have a very different set of requirements than we do in consumer and industrial. So automotive, we have to adhere to ASIL safety. And there's 4 different levels of that and really a 5th. One's called quality managed, and then the others are ASIL levels 1 through 4. And those are basically the safety levels based upon, you know, I like to say ASIL D means death. It's how, right, how much failure you can tolerate in the component. Now, with a computer, for example, if your battery were to shut off, it's not a big deal. If your battery shuts off in your vehicle while you're driving down the road, that's life or death. And as a result, we have to have a lot more redundancy built in. And we introduce these topics, functional safety. And the vehicles have to have functional safety built in. And so, although we have a lot of the same functions and features that are found in consumer devices, we have to build a lot more safety into the chips, depending on where they're used. So, for example, I mentioned USB PD controllers. On the ASIL scale, those are QM, or quality managed. If your USB charger stops charging your phone in the car, it's not a problem, not a big deal. But if your traction reverter suddenly stops and you lose control of your vehicle on the highway, that's life or death. And so what that means from a design side is we have to have certain features and tests and checks to make sure that circuit works properly, the software works properly, the calculations work properly. And that's done through a series of redundant features, as well as calibration and measurement, and just checking the circuit.
Well, I must admit that was a leading question because of what's happening with the flight control systems now. Right, that's a leading question. You know, I hosted British Airlines here, and they corrected me right away. They said, no, we are British Airways, not airlines, right? And they were creating, at the time, they had a lecture on how the airplane could fix itself, in the air, right? The importance of it for the navigation system. Are airplanes getting too complicated to fly? As an old, helicopter Vietnam guy, they might be getting too complicated looking at those things fly. So tell me about when I turned the news on and they said that our systems for communications for flight control, they're just so old. Talk to me about what will you do to control it? How would it change? How do we need to upgrade them? And that was the leading question before, right? Yeah.
Ooh, so it's going to take me straight out of my expertise range. It's a very complicated topic. So mixture of the FAA and it sounds like we're also talking about air traffic controllers, as well as maybe the flight controls of the aircraft as well. So that's tough to approach. So it's a large integrated system. And so if we're talking about air traffic control itself, it's a system that has to be infallible. It's built upon humans
that we have. Right.
Yeah. Yeah.
But
And
isn't Bryan with what is the name of? Can you elaborate on what's going on with autonomous vehicles? Isn't it similar concept? I mean,
Same thing. Yeah.
Yeah. So, for example, for drones and air traffic control, right now we have air traffic controllers, and they do a phenomenal job. It's an incredibly stressful job. They have to talk to pilots, and the problem is they can't control the pilots. They can only give recommendations. And it's a fault tolerant system built on that, where you're trusting experienced pilots to make the right judgment call with guidance from ATC. Now, with drones, now we have a whole bunch of autonomous vehicles in the mix. And ways we make them safer is we limit the altitude they can fly. We limit the geographic areas they can fly, just as we do with pilots and different class ratings. But the problem is we don't have that experienced pilot operating that drone. One, and then two, scalability. And this is where it comes to bite us. We have tens of thousands of flights a day in the entire country. What happens when you have 5,000 delivery drones in just one city, in one small, tight geographic area? And two, trying to tie that into a system where we don't have pilots making the calls.
Yeah, I have a theory, a hypothesis that planes are becoming maybe too complicated to fly, to babysit. In the sense that the old saying was that you're going to have two things in the cockpit. You're going to have a pilot and a dog, and a pilot to watch the controls, and a dog to bite the pilot if he touches the control. I think given your industry, if you look at safety, emergency system, if you look at communication and navigation systems, my leading question was, how would chips change to make those things better? And are things getting too complicated? Is the Huey helicopter was easy to fly? It was a bicycle. The helicopters now, they're just games. You just babysit those things, right? And what you just said to me was that the human element must catch up to, right, to the control system we now have. And to me, that's a huge question. I mean, when I go to the supermarket when I was growing up, you went to the supermarket and you got behind the person who could type in the numbers real fast. Now they just go beep, beep, beep. Technology, right? Dumb down technology. I think technology dumb down things on the one hand, but then makes it more complicated to use on the other hand. So I asked you that question because was to what extent are your chips becoming more sensitive as you move forward, the technology itself?
Well, that's a great point. It's one of the reasons why we have this push towards software-defined vehicles. So the homogenization of everything, the bringing together of everything, all of our signals and our sensors. So if we look at just autonomous vehicles, let's look, for example, how Waymo's done it as opposed to some other manufacturers. They've pretty much created a module that they go and they strap on these pace cars, and it replaces the driver. It's meant to replace all the inputs. It does it with a multitude of sensors. The thing with these systems is they work very differently than humans. Computers are great. They're fantastic at pattern recognition. Do it incredibly well. Humans, we're limited to binocular and in some cases monocular vision when driving. And if we're blessed with the ability to hear, that's about it. Whereas vehicles, they can get sensor data from a multitude of sensors. So with humans, sensor overload, that can happen. With computers, it just adds more points to the cloud and actually helps them out. The problem is really, it's one way to look at it, it's weird ways. Humans, like in an ideal environment, it would just be a whole bunch of computers driving computers. Humans are the hard thing to anticipate. How's a human going to react?
Yeah,
right?
I think so. And that this is why, as a predictive statistician myself, this is why we will always have trouble. I mean, with physics, a rock will always do what it wants to do, right? So physics never excited me. So you drop a rock, it's its own raise drop. But humans will always change their mind. And when we try to write equations for humans, it becomes very, very difficult, whether it's economic equations or whatever have you, because it would change its mind. Well, let me just say this to get back on point here. I want to ask you about the industry itself, right? Get back on point in terms of the industry. Tell me your biggest thing that keep you awake for a startup in your industry. I would think is wood materials where you got to change your supply chain. But what keeps you up at night when you think about you've got to keep your startup going? Because remember, you're in the industry like the computer industry when it started. Everybody wants one. Everybody wants one. It was no problem, Go back to Michael Porter's industry analysis. You can't go wrong by starting a computer company, in 1975. Everybody wants one. Now everybody needs chips. So what keeps you awake for your startup?
So for me, and this is because I'm a product guy, unfortunately, it's a boring answer. It's going to be product market fit.
Yeah.
And trying to ease into that, especially when there's so many incumbents in the space that do such a great job at the products that they create. A lot of the incumbents, either through subsidies or specific technologies, they have an edge. And we have to compete with that while being fabless, which means sometimes we have higher costs. Now, of course, we use our advantages as much as we can, but it's hard to attack an entrenched market. Get those first customers on board and deliver that product so you can start iterating on it. So that's the wishy-washy answer. To be a little more specific, it's getting, finding that niche. And with so many product lines that we've worked on, we've been able to find that in several products. But every time we talk with the customer, design in, sometimes that story changes, and then we rip up and iterate. And so, but that's our strength is nimbleness.
Yeah, and I think that's a great strength to have, because I think, again, my theme has been, it's changing tremendously. The supply chains would change, the materials would change, and how you manage all of that would change. But what would not change is the demand.
So Bryan, let's talk about energy storage and battery energy management systems and all that. So what's going on there? What's the latest and greatest?
So energy storage, it's just one of those fields that's absolutely exploding. We have huge demand and need for it, from the grid side to vehicles, to home and industrial. So just to put a fine lid on it, we need to more than double what our capacity is, energy generation. And one of the ways we do that is with renewables. Battery storage systems help us with renewables. They help us solve that problem of the wind's not blowing or the sun isn't shining. But that's just one slice of the equation. They also help us with peak load and peak demand. So instead of having to fire up a turbine at a data center, when we start having heavy AI workloads or heavy workloads, you can actually use battery storage systems to supplement and handle that peak load. So that there's just a large explosion in the industry. There's a huge need for them, and from everything from vehicles to your vehicles being your energy power wall, to power walls throughout. Now, what I'd love to dive into and try and keep it at a higher level is all the different technical aspects involved in that.
Don't keep it high level. Dive into it. That's what I'm asking you.
All right. So is there anything in particular that interests you on energy storage?
Well, I'm asking you so that our listeners can understand what's the latest and greatest.
Okay, great. So when it comes to designing energy storage systems and battery management systems, what we're seeing is just an explosion in the voltages and the capacities that we need to handle. In vehicles, we're seeing the storage needs increase. We have voltages increasing on EVs from 400 volts to 800 volts. Now BYD's announced that they're up to 1,000 volts. And with these increases in voltage, we're able to charge at the same rate with less current. So for 400 to 800, if you maintain that same current, you are now charging twice as fast, and it's a real game changer. We are now with batteries being able to charge them 15 minutes to get the range. We're on the vehicle side approaching the utility of filling up at a gas station. Problem is infrastructure and building it out. And that's where we really need to see big gains, big investments, and big changes. We're seeing it in other parts of the world. I'd like to see more of it here in the US.
So what materials? So it's are the cars going into silicon carbide and gallium nitride? What's going on there?
Yeah, so we're seeing a lot of different changes in these systems. So, for example, traction inverters are seeing a lot of silicon carbide that's necessitated by these higher voltage stacks and the lower frequency at which we operate the traction inverters. We're seeing GaN also proliferate through the systems and like onboard chargers, DC-DC converters. And that's just on the switch nodes. We're also seeing a revolution in the chemistries themselves. The energy density is increasing across the board. Of course, that comes at cost. And we're also seeing different chemistries come on board. So, of course, lithium iron phosphate, and also a big push towards solid state batteries as well.
Okay. And again, Bryan, when you think about talent, so the talent is kind of Germany, Texas, Silicon Valley, Japan, L&T is now trying to build talent in India, obviously China. How hard is it to find talent? So if I wanted to find a autonomous vehicle semiconductor designer, how many of those people are alive in the world? 10, 100, 1,000? How many people know that stuff?
Well, it's growing every day. Of course, we have large centers of excellence there throughout the world. Surprisingly, you'll find a lot of them in Detroit, Indiana, right in the heartland of the United States. You also find them in China. China's been booming. But you can find them throughout the world, but it is tough because we're looking for people with a power engineering background, as well as some cross-domain knowledge, and it can be tough.
Well, I find that very interesting because it's like computer science. It can become I wouldn't call it an OJT, but the more experience that you have, right, the better it gets. In the sense that computer science really came out of logic and then migrated to the university as a discipline. So I guess what he's saying is, what do you need to be a top grade engineer? Remember that the Ford Motor Company just took people who had great perception and made great engineers out of them. They never went to a college, in other words. I mean, how do you see the progression of your workforce?
So it's one of those. It's not gonna like this answer. The most important thing is willingness to learn and the inability to accept no as an answer. You need someone that's able to just dive into the material and learn. And that's what we look for when we're hiring new engineers out of college. For the more experienced engineers, they've been doing it a while, and we tend to hire exactly what we're looking for. But as for the coursework, power electronics, high voltage, current, understanding switching theory, it's and control loops. It really depends. You need a whole team of engineers to put these systems together.
So how's Austin, Texas? Are we still holding our lead in since Symantec jumped and left us? I mean, we went way down for a while, as Andreas pointed out. We're now at the center. How do you see startups in Austin? Where are we contributing to the semiconductor industry?
There's a lot of talent in Austin. So we might have lost Semitek, but we still have a lot of players here in town. They don't call it Silicon Hills for nothing. Downtown, we've got Cirrus Logic. I used to work there. We also have sales offices from all the other companies. And like, for example, Texas Instruments even has a small design center down here that not many people know about.
The IBM and yes.
Yep.
We got
of course, the bigger players.
Yeah, we have a lot of companies here, but in terms of the headquarters, Carol Thompson, Silicon Hills was given to us by Carol Thompson, who, by the way, just went into the Austin Technology Hall of Fame last week. So I think, see, I asked the question because you can have a lot of companies come here that are doing things right, but then we can have startups that actually do stuff because the startups, I mean, they love Austin, or I mean, we have a Dell Computers, right? And then we have a Dell Hospital, but you're going to have Microsoft is going to be in Seattle, right? It won't do that kind of stuff in Austin. So that's why I was asking about the talent and the growing talent. Yeah.
Well, so fortunately in Austin, we have a rich talent pool. We have the University of Texas at Austin, and it's a great place to come and work. We have incumbents from National Instruments on through of all the big semiconductor names. It's we see a lot of companies moving here as well.
Yeah.
Yeah, Austin is it's really well located. We have Dallas less than 3 hours away, and Houston as well. And so we're just in that Texas triangle. It's one of those things we're just going to see keep growing.
So Bryan, what are you working on right now? Tell me one or two things you're working on right now. Go in detail, please.
All right. So two main things: USB PD controllers and delivering high power. So that's in the vehicle. We're developing a source controller, and our claim to fame is being able to deliver 100 watts all in package, which is industry first.
Okay. Interesting.
And then
John, go ahead.
Yes, sir.
What else you got? What else you got?
Well, I think, the semiconductor industry since our very, very beginning with the Austin experiment has been very, very dear to me. And when we lost, we thought we had lost it for a while. And because of people like Bryan, we brought it back. We thought we had lost it to North Carolina. And we worked very, very hard to get it here. And, it came here with, as MCC was locating here. And so the industry became, we used to say, do local stuff, but go international. And it's obvious that Bryan has done that. So I think that he's in the very, very center, obviously. I mean, whether it's air travel, autonomous cars, or whatever the case might be. What a great, great scientific endeavor to be in, and again, I love your phonographs in the background.
Thank you, Cameron.
Okay, well, we are always looking forward to learning more about what's going on in automation in the industry, and so semiconductors play a key role of where things are heading. So, thank you for spending some time with us. And what's next in front of you the next 6 months? Are you going to any events? Are you traveling? Are you doing anything interesting related to the business and the job? You got some trips to some other locations in your company. Anything to share about that?
Yeah, so right now I've been finally we just kicked off our USB PD product, and now I'm moving to push more of my energies into actually battery energy storage. For us, there are a few trade shows that we're going to be at. We have a pretty interesting demo that we're going to be showing at Semicon, India, I believe.
Okay. John, any final thoughts?
No, I think it's good. I think that it's great to have a startup in Austin. I see them interacting with India. I think that's a wonderful thing. I think that the world is tied together and networked from that point of view in the business world. And it's good to see that Bryan is working on one of the great areas that goes is cross-fertilization with so many products, and especially related to safety in the future. We haven't even started talking about home security, semiconductor, and that kind of stuff. It's just at the center. It is the new engine, if you will, for the safety in the world.
Great. All right. Well, thank you, Bryan. And Johnny, take us away.
Let's play the first song that was played on that damn thing behind you. Oh, the years creep slowly by, Lorena. snow is on the ground again. The sun's low down the sky, Lorena. The frost gleams where the flowers have been. But the heart beats on warmly low now. As when the summer's days were nigh. Oh, the sun can never dip so high. Or down life's affectionless cloudless sky. The first love song played on that contraption behind you. Look it up and listen to it. It's an American tradition.
Thank you, Brian. Thank you.
Thank you, Brian. Take care.
Thank you, John.
Thank you, Kahler.
Right. Bye-bye.
Take care now.
Mm-hmm.